Good day everyone, welcome back to a continuation of our discussion on the topic application of differentiation. Today we will be discussing gradients but purely implicit function. Our very first question says that find the gradient of the curve y square s plus 3s square y equals to 1 at the points 1 and 1. First, we differentiate implicitly, and from our knowledge of implicit differentiation, doing so it becomes y squared times ds over ds plus s times dy squared over ds plus 3s squared dy over ds plus 3y times ds squared over ds is equals to 0. Simplifying further, it becomes y squared plus s times 2y dy over ds plus 3s squared dy over ds plus 3y times 2s ds over ds is equals to 0. See, breaking it down, it becomes y squared plus s times 2y dy over ds plus 3s squared dy over ds plus 3y times 2s is equals to 0. Simplifying further still, it becomes y squared plus 2sy dy over ds plus 3s squared dy over ds plus 6sy is equals to 0. At this point, we are going to be collecting like terms. Collecting like terms, it becomes 2sy dy over ds plus 3s squared dy over ds will be equals to minus in bracket y squared plus 6sy. Now we are going to be factorizing our left hand side, that is bring dy over ds out. Factorizing dy over ds in bracket 2sy plus 3s square will be equals to minus in bracket y square plus 6sy. To make dy over ds stand alone, we are going to be dividing both sides by 2sy plus 3s square. Dividing both sides by 2sy plus 3s square, dy over ds will be equals to minus in bracket y square plus 6sy divided by 2sy plus 3s square. At the points 1 and 1, s is equals to 1 and y is equals to 1. Now substituting y to be equals to 1 and s to be equals to 1, dy over the s will be equals to minus in bracket 1 plus 6 divided by 2 plus 3, which will be equals to minus 7 over 5, and converting into mixed fraction to be minus 1 number 2 over 5. Our next question states that the gradient of the curve s squared minus 2sy minus 2y squared minus 2s equals to 0 at the points 1 and minus 4 is. First, we differentiate implicitly, and doing so, when we have a component that is purely s, we differentiate it with respect to s. If it has s and y, we differentiate with respect to s taking y as a constant, then we differentiate with respect to y taking s as a constant. If it's purely y, we differentiate with respect to y. Mind you, whenever we are differentiating with respect to y, in our final answer we will be adding dy over ds. So doing so, s squared becomes 2s minus 2sy becomes minus 2s dy over ds. That's differentiating with respect to y. Then minus 2y, that's differentiating with respect to s. Minus 4y dy over ds, that's differentiating minus 2y squared with respect to s. Minus 2, because when we differentiate 2s, it becomes 2 equals to 0. At this point, we are going to collect terms in dy over ds together. Doing so, it becomes 2s minus 2y minus 2 is equals to 2s dy over ds plus 4y dy over ds. Next, we are going to be factorizing our right hand side. Doing so, our equation becomes 2s minus 2y minus 2 is equals to dy over the s in bracket 2s plus 4y. Now to make dy over the s stand alone, we are going to be dividing both sides by 2s plus 4y. Dividing both sides by 2s plus 4y, 2s minus 2y minus 2 divided by 2s plus 4y is equals to dy over the s. So simplifying our left hand side further, we are going to be factorizing. Doing so, it becomes 2 in bracket s minus y minus 1 divided by 2 in bracket s plus 2y is equals to dy over the s. 2 in the numerator and 2 in the denominator is going to cancel out. So therefore the y over the s will be equals to s minus y minus 1 divided by s plus 2y. At the points 1 and minus 4, s is equals to 1 and y is equals to minus 4. So substituting 1 for s and minus 4 for y, the y over the s will be equals to 1 plus 4 minus 1 divided by 1 minus 8, which is equals to minus 4 over 7. And the correct option is B. Our next question states that given the curve 50s squared plus 36sy plus 5y squared is equals to minus 2, evaluate the y over the s at the points 1 and minus 2. Differentiating implicitly, we have that we are going to be differentiating each of the individual components. 50s squared becomes 50 the s squared over the s plus 36sy will be done twice. That will be differentiated with respect to s and differentiated with respect to y. Doing so, it becomes 36s dy over the s plus 36y ds over the s plus 5 dy squared over the s will be equals to 0. Simplifying further, 50 the s squared over the s will give us 100s. That's the s squared over the s is 2s, and multiplying that by 50 will give us 100s. And 36s dy over the s will remain the same, which will be 36s dy over the s plus 36y ds over the s will become 36y plus 5 dy squared over the s will be 10y dy over the s. One will differentiate y squared to give us 2y. 2y times 5 is 10y. And since we are differentiating it with respect to s, it becomes dy over the s. And everything will be equals to 0. Our next step is to collect like terms or collect the terms in dy over the s together. Doing so, our equation becomes 36s dy over the s plus 10y dy over the s will be equals to minus in bracket 36y plus 100s. Our next step is to factorize our right hand side. That's bringing the dy over the s out. It becomes dy over the s in bracket 36s plus 10y is equals to minus in bracket 36y plus 100s. Our next step is to divide both sides by 36s plus 10y to make dy over the s stand alone. Dividing both sides, dy over the s will be equals to minus in bracket 36y plus 100s divided by 36s plus 10y in bracket. Now at the points 1 and minus 2, s is 1 and y is minus 2. So we'll be substituting s for 1 and y for minus 2. Substituting both of them, dy over the s will be equals to minus in bracket 36. Then for our y, we put in minus 2. That's minus 2 being in bracket plus 100. Then in place of s, we put in 1. That's 1 in bracket. Divided by bracket 36. Then for s, we are putting 1 plus 10 in bracket minus 2. That's for y, we are putting minus 2. Now simplifying further, dy over the s will be equals to minus 36 times minus 2 is minus 72 plus 100 times 1 is 100. So it's minus 72 plus 100 divided by 36 times 1 is 36 minus 10 times minus 2 give us minus 20. So dy over the s is equals to minus in bracket minus 72 plus 100 divided by 36 minus 20. Simplifying further, minus 72 plus 100 is 28 and 36 minus 20 is 16. 28 over 16 will be equals to 7 over 4. That is where our final answer will be equals to minus 7 over 4. Then converting into mixed fraction, that's minus 1 over 3 over 4. We have another question that states that find y prime, that's the y over the s, at the points 1 and 1 if s squared y plus y cubed is equals to 2. And we are given the solution. Now very first step is to write down our equation. S squared y plus y cubed is equals to 2. Now from implicit differentiation, since the first component has both s and y, we'll be differentiating it twice. The first case, we will differentiate s treating y as a constant, and the second case, we will be differentiating y treating s as a constant, then add the y over the s. And when we are differentiating the component that is just y, that's y cube, we differentiate it normally and we add the y over the s. So doing so, differentiating s square y plus y cube equals to 2, it will give us 2sy. That is, we are differentiating just the s components. That the derivative of s square is 2s, and we are treating y as a constant, so it's 2sy plus s squared dy over the s, because when you differentiate y, it becomes 1. So s squared is a constant, so it becomes s squared dy over the s, plus 3y squared dy over the s will be equals to 0. The next step is to collect like terms. That's all our components with dy over the s should be in one side and the rest on the other side. Doing so, it becomes s squared dy over the s plus 3y squared dy over the s is equals to minus 2sy. At this point, we are going to be factorizing our right hand side. That's to make the y over the s out. So doing so, it becomes s squared plus 3y squared in bracket dy over the s is equals to minus 2sy. Our next step is to divide both sides by s squared plus 3y squared to make the y over the s stand alone. And when we do that, the y over the s will be equals to minus 2sy divided by s squared plus 3y squared. At the points 1 and 1, we are going to be substituting s to be equals to 1 and y to be equals to 1. Substituting, the y over the s will be equals to minus 2 in bracket 1, another bracket 1, divided by 1 square plus 3 in bracket 1 square. Simplifying further, the y over the s will be equals to minus 2 divided by 1 plus 3, and the y over the s will be equals to minus 2 over 4, which when broken down should be equals to minus 1 over 2. And the correct option is B. Our final question is from NECO 2021. It states that given that s cubed minus y squared minus 2s plus 2 is equals to 0, find the y over the s at the points 1 and 1. Now, solution, the first thing we are going to do is write down our equation. And recall that when we are differentiating a component in our equation that has just s, that is, we are going to be differentiating it normally. If it's just y, we'll be differentiating it and adding the y over the s. Doing so, differentiating our equation, it becomes, when we differentiate s cubed, it will give us 3s squared. When we differentiate y squared, it will give us 2y dy over the s. When we differentiate 2s, it will be equals to 2. And since 2 is a constant, it will be 0. So summing everything together, differentiating s cubed minus y squared minus 2s plus 2, it will give us 3s squared minus 2y dy over the s minus 2 is equals to 0. The next step is to separate the y over the s, or the component with the y over the s. Doing so, 3s squared minus 2 will be equals to 2y dy over the s. That is, we brought minus 2 dy over the s to the other side, and since it's crossing over, the negative sign changes to positive. At this point, we are going to be dividing both sides by 2y to make the y over the s stand alone. Dividing both sides by 2y, it becomes 3s squared minus 2 divided by 2y will be equals to dy over the s. Similarly, dy over the s is equals to 3s squared minus 2 divided by 2y. At the points 1 and 1, we are going to be substituting for s equals to 1 and y equals to 1. So substituting s and y to be equals to 1 in our dy over the s solution, dy over the s therefore will be equals to 3 in bracket 1 square minus 2 divided by 2 in bracket 1, which will be equals to 3 minus 2 divided by 2, which is equals to 1 over 2. We have some exercises for you to try your hands on. And for answers to this question, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy at bookshops, or if you are interested in the soft copy, you can get that at the website on the bottom of the screen. Thank you.